Autumn, 1918. The world is already drowning in blood. World War I rages across Europe. Trenches are soaked in mud and misery. But something far more terrifying begins to spread, not through bullets or bombs, but through breath. In the shadows of the battlefield, soldiers begin to collapse, not from wounds, but from fever. High, unrelenting fever. Coughs turn into blood. Lungs drown from within. One moment, they're writing letters home. The next, they're dead. Not weeks, not days, hours. Cities go quiet. Families vanish overnight. The dead are too many to bury. And in every corner of the globe, the same question rises in a whisper of fear. What is this? The newspapers call it the Spanish flu. But Spain is not the origin. It's just the first country brave or free enough to talk about it. The true source remains hidden, buried beneath layers of war, secrecy, and time. In just over a year, it infects more than 500 million people and kills at least 50 million. Some say 100 million. No plague in modern history moves this fast. No virus kills this efficiently. And yet, for more than a century, its origin has remained one of the greatest medical mysteries of all time. Was it born in the trenches of France? In the dusty plains of Kansas? Or did it emerge from somewhere far more unexpected? Now, over 100 years later, science has finally caught up with the silence. Through the power of ancient DNA, scientists have uncovered frozen genetic fragments preserved in forgotten graves. Fragments that rewrite everything we thought we knew. What they found doesn't just solve the mystery. It opens the door to something far more chilling. Because the Spanish flu never truly disappeared. And what it left behind is still inside us. So now we must ask, where did it come from? And can it come back? 18 wasn't just the end of a war. It was the beginning of a nightmare. As soldiers returned home, they carried with them more than just trauma. They carried something invisible, something unstoppable. The Spanish flu spread like fire through dry grass. In New York, it killed over 20,000 in less than 2 months. In India, more than 17 million people died. In Iran, 1 out of every 5 citizens vanished. Australia tried to seal itself off, but the virus found a way. From the Arctic to remote islands in the Pacific, no corner of the world was safe. Ships became floating coffins. Schools turned into morgues. Weddings turned into funerals. In Alaska, entire Inuit villages were found frozen in silence. Everyone dead. Bodies untouched. Meals still on the table. And unlike any plague before, this one targeted the young. Healthy men and women in their 20s and 30s. The strong were the first to fall. Doctors were baffled. Autopsies revealed lungs filled with blood and fluid, as if the body was drowning from the inside. The virus triggered something no one had seen before. A cytokine storm, where the immune system went into overdrive, attacking the body it was supposed to protect. And the global medical system? Completely overwhelmed. Hospitals ran out of beds, nurses, even coffins. Cities imposed mass burials. In Philadelphia, bodies were stacked on sidewalks. In some places, people dug graves with kitchen spoons. Despite its unimaginable scale, the pandemic left almost no cultural scar. There are no memorials, no annual remembrances, no museums. It's as if the world agreed to forget. Historians still debate why. Maybe it was the trauma of war or the speed at which the flu vanished. But the silence is deafening. For over a century, researchers searched desperately for patient zero, for ground zero. Reports pointed in all directions: a military camp in Kansas, a hospital in France, even a rural village in China. But every lead ended in dust. The virus left behind no witnesses, no origin story, just death. Until now. Because buried in the cold earth of forgotten graves, something ancient was waiting, something microscopic, something with answers. It began in a place forgotten by time. Breivik Mission, a remote village in the permafrost of Alaska. Isolated, frozen, silent. In 1918, the Spanish flu reached even this distant corner of the earth. In just 5 days, it killed 72 out of 80 residents. The survivors buried their dead quickly, fearing the spread, digging a mass grave in the frozen ground. Then they left. The grave was sealed by ice, preserved by cold, and for decades it remained untouched, until the 1950s, when a young pathologist named Johann Hultin heard whispers of a grave that might still contain the virus, locked inside the lungs of the dead. Driven by obsession and scientific curiosity, he traveled to Breivik with permission from the elders and began to dig. What he found was astonishing. Deep beneath the permafrost, the bodies were almost intact. Hair, skin, even internal organs had been preserved by the ice. Hultin removed samples, hoping to resurrect the virus in the lab, but the technology of the time failed him. The virus would not yield its secrets. The samples were archived, the grave refrozen, and the mystery remained. But Hultin never forgot. And decades later, when DNA sequencing had finally caught up with ambition, he returned, this time with a team of virologists and a very specific mission: to extract the ancient genetic code of the Spanish flu. In 1997, they uncovered the body of an Inupiat woman, known only as Lucy. Her lungs were perfectly preserved. The team carefully removed samples of her tissue and flew them to a high-security laboratory. There, using new techniques in molecular biology, scientists began to sequence fragments of the virus, one piece at a time. It was the first real glimpse into the biological identity of the killer that had haunted the 20th century. But what they found was even stranger than they had imagined. The Spanish flu wasn't just an unusually deadly strain, it appeared to be something entirely new. A virus with pieces of genetic material unlike anything seen in the flu viruses circulating at the time. For the first time, humanity stood face to face with the ancient code of a virus that changed the world. And the more they decoded, the more terrifying it became. In the sterile silence of a high-containment lab at the CDC in Atlanta, scientists worked like detectives at a crime scene. Gloved, masked, isolated. Every sample of tissue from Lucy's lungs was treated as if it were alive. Because if they were right, if they managed to reconstruct the virus, then for the first time in modern history, the Spanish flu would be reborn. Under extreme biosafety protocols, they began to amplify the viral RNA, fragment by fragment, a puzzle with no picture. But what emerged from the sequencing was chilling. The virus wasn't simply a mutated strain of common flu. It was a perfect killer, composed of genes that had never before existed in that combination. It had adapted to jump from birds to humans with terrifying efficiency. And no one knew exactly when or how that leap had occurred. The team used reverse genetics to reconstruct the full virus, placing the ancient RNA into living cells. The cells responded instantly. The virus came alive. It replicated fast, aggressively, attacking lung tissue with a ferocity they had only read about in historical reports. It was now clear. The 1918 virus had avian origins. But it wasn't a direct bird-to-human transmission. There was a missing link, an intermediate host. Something had allowed the virus to adapt, mutate, and become airborne among humans. But what? The search turned global. Scientists examined preserved tissues from World War I soldiers. They analyzed frozen samples from museum archives. They modeled the spread of the virus across military routes, migration paths, and trade lines. And again, their trail kept circling back, not to Europe, not to Spain, but to Camp Funston, a military base in Kansas. In early 1918, soldiers there began collapsing from a strange illness, high fever, violent coughing, rapid death. The outbreak was covered up, dismissed as common flu, and the men were shipped off to Europe, carrying death with them. Historians and virologists debated endlessly. Was Kansas the origin, or just the first spark? The virus's genetic code held clues, but not enough. It was like reading an ancient language with half the letters missing. But then, in 2005, a new breakthrough came from an unexpected place. Preserved pathology slides, nearly a century old, stored at the Armed Forces Institute of Pathology. These samples allowed researchers to fill in the missing gaps of the genome. And what they found pushed the mystery even deeper. The virus didn't just emerge suddenly in 1918, it had ancient roots. Genetic markers revealed that parts of its code dated back decades. The killer had been evolving in silence, hiding in birds, and, perhaps, pigs, long before it made its move. Now, the question was no longer just where it came from, but what had triggered it to awaken. By 2005, after nearly a century of silence, the Spanish flu finally spoke. Using preserved lung tissue from both Lucy in Alaska and multiple U.S. military victims stored in formalin-fixed slides, scientists reconstructed the entire genome of the 1918 influenza virus. It was an unprecedented achievement, decoding not just the shell, but the full internal blueprint of a virus that had killed tens of millions. The results stunned the medical world. The virus, now designated AAH1N1, was confirmed to be of avian origin, but with unique human adaptations. It wasn't a mutation of human flu. It was a hybrid, a virus that had spent years evolving in animal hosts, gradually reshaping itself for human transmission. And then, suddenly, it struck. What made the 1918 strain so deadly wasn't just how fast it spread, it was how it hijacked the human immune system. The virus carried specific mutations in its hemagglutinin, HA, and polymerase genes, allowing it to bind tightly to receptors deep in the lungs, triggering massive immune overreactions. Young adults, with the strongest immune systems, were ironically the most vulnerable. Their bodies attacked themselves. Autopsies confirmed the same gruesome pattern. Perfectly healthy lungs destroyed in hours. The genetic data also showed that the virus hadn't come from a slow seasonal evolution. It was the result of a sudden genetic shift, likely from an event known as antigenic reassortment, a viral collision between species. The smoking gun. Genetic signatures pointing to North American avian strains mixed with hints of swine and human influenza. This wasn't just one virus, it was the product of a viral meeting point, a place where birds, pigs, and humans lived in close proximity. And that place, all signs suggested, was rural Kansas. On farms where soldiers trained beside livestock, where migratory birds passed overhead, where biology blurred the boundaries between species. The samples from Camp Funston matched early patterns of the pandemic's genetic code. It had started there, quietly, invisibly. A single viral mutation, then a chain reaction. But what truly shocked scientists was how modern strains of H1N1 still carry remnants of that same 1918 genetic material. In fact, the seasonal flus we face today are distant echoes of the Spanish flu, its descendants still mutating, still circulating. The 2009 H1N1 swine flu pandemic? Genetically related. A reminder that the virus never truly died. It simply changed its face. And in that discovery lies a terrifying truth. The killer that once drowned the world in silence may still be with us. It began with a whisper, invisible, untraceable, a droplet, a cough, a moment. Somewhere in Kansas, early 1918, on a farm thick with life, pigs, birds, humans, an ancient avian virus collided with another strain. Inside the lung of a pig, the genetic material fused, and in that microscopic moment of chaos, something monstrous was born. A new virus, a perfect storm of animal and human code. The first human host was likely a farmhand, or maybe a young recruit at Camp Funston. He didn't know he was carrying a killer. He had no symptoms, not at first. But in his throat, the virus was replicating, fast. Days later, he developed a fever. He coughed. He spread it. Within a week, over 1,000 soldiers at the camp were sick. Some recovered. Others died quickly. The army silenced the outbreak. War came first. The men were shipped to Europe by the thousands, packed in trains and ships. And so was the virus. In the cramped trenches of France, the killer found fertile ground. Mud, blood, rats, hunger, terror, conditions perfect for infection. Soldiers coughed. They vomited blood. They died in piles. And still, no one understood what was happening. From there, it exploded. Paris, London, Berlin, New York, Bombay, Sydney. One infected person could trigger a cascade. Ships became floating incubators. Trains carried the sickness to villages untouched by war. By fall, the virus had mutated again, faster, deadlier. In its second wave, it killed with horrifying speed. People collapsed in the streets. Some were dead by sundown, lungs filled with fluid. Skin turned black. Families were wiped out in days. In one instance, a healthy young woman was dancing at a wedding. By morning, she was gone. Newspapers couldn't keep up. Governments tried to hide it. Priests gave last rites from sidewalks. Entire cities ran out of coffins. Then, almost as quickly as it appeared, it faded. By mid-1919, the Spanish flu seemed to vanish. No vaccine had been created, no miracle cure. It simply burned through the population, left millions dead, and vanished like smoke. But it didn't die. It changed. It left behind genetic seeds in the viruses we still fight today. Its story, long buried, has only now begun to be fully understood. And when we reconstruct the events, when we look at the timeline, the conditions, the biology, we realize this wasn't a once-in-a-century anomaly. It was a warning. The Spanish flu wasn't just a tragedy of the past. It was a mirror held up to our future. It revealed how fragile civilization truly is, how easily global systems can crumble under the weight of something we cannot see. A virus smaller than a grain of dust brought the world to its knees. It exposed weaknesses in medicine, government, and communication. And for decades, it remained a ghost story told only in medical journals and whispered memories. But now, through ancient DNA and the power of modern science, we've pulled it out of the shadows. We've mapped its genome, traced its lineage, and revealed its true point of origin. And in doing so, we've learned something chilling. It never really left. The genetic fingerprint of the 1918 virus is still with us, in modern flu strains, in seasonal outbreaks, in pandemic threats waiting to emerge. It evolved, reshaped itself, and continued to circulate through pigs, birds, and humans. It is a virus that sleeps in cycles, a reminder that nature never forgets. The lessons of the Spanish flu echo loudly today. Rapid transmission, global travel, misinformation, political denial, patterns we've seen repeat in the modern world. And still, the question lingers. If such a virus rose once in silence, could it happen again? The answer isn't just scientific, it's existential. Because now we know where it began, how it moved, what made it deadly. And yet, we are still vulnerable, still exposed. The mystery has been solved, but the danger remains. The past has spoken, but will we listen? If this journey through history and science intrigued you, don't forget to like, subscribe, and turn on notifications. We dive deep into untold stories, hidden codes, and the forgotten forces that shaped our world. There's always another mystery waiting, and DNA never lies.